All right, so before the break, we talked about transformations of two functions. So we're going to be doing 3 total. Today will be our 3rd. The first function was y equals x squared, and then the other function was a square root function. So there may be 2 ways that I express questions to you. One of them will be you get the parent function. So the parent function is y equals root x, and then you get the transformation equation. The other way you might see is you might just see a combined equation already. So we worked on combining them ourselves and then labeling our graphs with that combined equation. This one is already combined, and you actually need to be able to identify what out of the 3 parent functions is the parent function of this equation here. So any thoughts on what that might be? Zion? Yeah, the parent function is, this part right here is kind of telling us information about that parent function. It's y equals, or you can call it g at x if you want, g at x equals x squared. So everything else in there is a transformation, right? We've got an a, we've got a d, and we've got a c there. But the squared part on that, that's the main operation of the function, and that's telling us what the most basic function is. It's y equals x squared. Okay, and I'm just going to review a quick thing just for those of you guys that weren't here for the quiz, because we did some work before the quiz on just kind of showing a step-by-step prediction of what this graph might look like when we do actual calculations. So you'll have to do this on your quiz today if you haven't written your quiz yet. But it's basically just kind of like predicting what each of these do and kind of showing a general sketch and then showing your final. So what we would show, if I wanted to just show a really basic step-by-step sketch of the transformations here, is we would start with the parent function. So this would be our first function. Call that g at x equals x squared. And then we would go along making sure that we do flips, stretches, and compressions first. We'd go along and show each of those transformations. So the first one, and if you have different colors, that can be helpful for this as well. The first one is this negative out front here. Does anyone remember what that would do? Elise? Horizontal or vertical? Yeah, okay, so this is like an a value out front here. So that's a vertical reflection, so we're just taking it and flipping it. So I'm going to label that number 1. The 2 part of this does something else. What would an a value of 2 do to my graph? Carla?
It's horizontal, stretch, or?
It's stretch part's correct. Sam, help him with the other? Vertical, yeah. Because it's the a value, right? So vertical stretch, imagine you're taking an elastic and you're stretching it out vertically. So we're going to work from the red graph, of course, because we've already flipped it and now we want to stretch it. So that will be what we get after the vertical stretch. And then usually I'm okay if you guys want to do transfer the translations or the shifts as one. So we'll call these 2 the 3rd. What is this telling me as far as shifts? What should I be shifting this blue graph to? Zion? Yep. Okay, so 3 to the right, because the d value, we need to switch the sign of that, and then 4 up. So you don't have to show like counting over, but 1, 2, 3, 1, 2, 3, 4, and then that's where my new graph is, the stretched version of that. And that will be the final graph. So I'm just going to label that as the final thing. So a couple reasons why we do this. Number 1, we basically just do this so we know the order of transformations. That's important, right? So this helps me to know that you know that the order of transformations is flips, stretches, compressions first, and then shifts last. This also helps us get kind of a prediction of what our final graph would look like once we do calculations. That way, if I do something wrong, then maybe I'll recognize that if I do a prediction first. Then I'll be like, oh, I must have done something wrong because this graph is on the other side of the, maybe you get it over there and you forgot to switch the sign of the d value, something like that. So that's why we do these predictions. So if you're writing the quiz today, you're going to be showing me something like this. Questions on this so far? Okay, so today is our,
Why is
Karen.
it flipped?
Because the a value is negative, so see how the a value is -2 there?
That just means to flip it?
Yeah, the negative part is the vertical reflection, and then the 2 part is a stretch. Okay, Carla?
So when we have, for our C value, when we're sort of like transforming up and
Yep.
over, it's -3, but then how do we know to move it right and up?
So the d value is always opposite of how it looks in the equation. So here, it's x minus 3, but the d value is actually positive 3,
Yes.
which is a shift right 3. So that's how we know. And then the c value is just as it looks. So if it's positive, it moves up. If it's negative, it goes down.
Okay.
Okay? Good. Okay. So last parent function out of the 3. Eventually, the goal is, of course, that all of these are going to be kind of mixed together. So I need to know if I get a question, I need to be able to identify, okay, this is the parent function I want to use, and these are the key points to that specific parent function. So I've been showing you these kind of all separated, but eventually you should be able to recognize which parent function you need to use just based on what the question is asking. So maybe it will ask you something like that warm-up asks you. Or it might just tell you explicitly in the question, the parent function is 1 over x, and then you guys will need to know which set of key points to use. So there's only 3 of them. So this is the last one, the last and final. So for this one, this is the one where we do -2 to +2, but we include the halves, and we don't include 0. Why specifically am I saying we don't include 0 here for this function? Elise? Yeah, because this is 1 over x, if I let my x be 0, I have 1 over 0, which we know we can't have. So I will exclude 0 from that, and then as we sub these in here, we'll get the y's. So we get -½ -1, and then when I sub in a -½ there, I end up flipping and multiplying and getting -2. And then same idea with these guys, but they're all just the positive versions of those. Okay? The other important thing here, this function has 2 asymptotes. It has a horizontal asymptote along y equals 0, or the x-axis, and it has a vertical asymptote. These are caused by restrictions along the y-axis or the line x equals 0. Okay? And if you imagine these asymptotes, like if I just show you with my arm here, I have a vertical asymptote. Now, if I shift up and down, is that vertical asymptote really changing location?
No.
Not really, it's staying at the same point. But if I shift my graph left and right, that vertical asymptote will actually shift with the graph, right? So my vertical asymptote is going to move with my d value. Okay, so if I have a d value shift, my vertical asymptote will shift that many units as well. And then again, if we imagine our horizontal asymptote, if I move horizontally, that stays at the same location, right? But if I move vertically, my horizontal asymptote will move as well. So the horizontal asymptote actually shifts with the c value. Okay, and for these guys, the one important thing to remember is that this is kind of like a 2-section function, so it has like 2 curves, and they're separated by imaginary vertical lines, which we call asymptotes. So it never crosses over those asymptotes, and it never touches them. Alex?
So same for h and a, y equals 0, and for b and a, x equals 0.
Yep.
How does a both y and x?
So, sorry, maybe I should have written out, this means horizontal asymptote, and this means vertical asymptote, not the a value. Okay? Okay, so what we're always going to do, yeah, Carlos, sorry.
Just that, those are always your default presets when you have.
Yes, yeah, and then they'll shift if we have any shifts in our function. Yeah, yeah. So what we're always going to do with these functions is we're going to start by drawing the asymptotes with dotted lines, just so we know where our graph needs to curve around, okay, and where it can't cross. So we're just going to pencil those in to start. And I'm always labeling my asymptotes with their equations as well. And then we'll graph our first set of 3 points, which should give us the first half of the graph, and then the other set. Okay, and I'm making sure as I draw my graph that I'm not crossing over the asymptotes, but I should curve kind of like near them and around them. Okay, and then the second half is up here.
Why are you drawing those like lines?
So these are caused by restrictions, because as soon as I have like something like a rational function, for instance, 1 over x, I get restrictions. So you remember in Unit 2 we talked about restrictions and what they produce on the graph. That's kind of what's happening here. So we get these kind of imaginary vertical lines that are, and horizontal lines that our graph avoids. Okay, so there's our function. Another just quick thought on this is, you see how one of these parts of the graph is down in the bottom left and one is up in the top right? They will always be diagonal across from one another. I'm never going to get two sections that are both in the bottom or both on the top. One will be on the top section of the asymptotes and one will be on the bottom section. They'll always be diagonal from one another when I transform them. So you should always end up with something that looks like this in the end. Carla?
So in terms of plotting, your
Yep.
x and your fx is basically just your y. So like
Yes.
Okay.
Yep, f at x is the same as y, yeah. Okay? Do we have our graphs? Okay. So I'm not going to do tons of examples today. We're just going to touch on how we write these as the final transformed equation, like how we label the graph, and then we're going to use these two guys right here and do the actual transformations, and that's pretty much it. So you guys should have a good amount of time to practice today. Okay, so I have just a general equation that I think is pretty helpful. And when I do transformations to the 1 over x function, or any of my parent functions, x squared or root x, the thing that I want to remember is that k and d always need to go where x is, because they're changes to x, and the a and c are kind of always on the outsides of the equation, right? So if I have the parent function 1 over x, and the k and d are going with the x, the k and d will actually end up being in the denominator with the x, where it is. So what ends up happening is I have like the a and of course the c on the outsides of the function, and then on the inside here, we have 1 over x, and the k and d go into the denominator with that x. So what it ends up looking like is kind of like this. Okay? And then what happens when we simplify this is the a actually just gets multiplied in. So the a will be in the numerator. So this is kind of how your final equation will look if your parent function is 1 over x. Okay, so k and d, the general rule is k and d should be with the x wherever that is. So when I do x squared, the k and d are with the x inside the squared, and when I do root x, the k and d are inside the root with the x. And then when I do 1 over x, the k and d are in the denominator with the x. Make sense? Okay, so when I go to combine these two, this is how I label my graphs in the end. I should also be able to look at a function in this format and be able to say, okay, the parent function is 1 over x, and here's the a, k, d, and c. So both ways, right? We should be able to make the equation and also see the equation in that format and know where a, k, d, c are. Okay, so if I have something like this, I have an a d, and a c. So then essentially if you want, you can just kind of plug it into that little skeleton there. Or what we're really doing is we're removing the f and then we're doing 1 over whatever is in the bracket there. So what we end up getting is 2 over x minus 1 plus 0.5. And that's again because our parent function is 1 over x. Okay, and then for the second one here, anyone want to take a stab at this one? Carla?
So you take away the f, so it's just -1.
Yep.
And then have -1 over x minus 0.5.
So don't change anything yet. We'll do that when we do calculations. So it should still look kind of like this.
Plus 0.5.
Okay. Where does the 2 go?
Outside the brackets.
Yeah. So we should have that. And then,
Plus c, so -1.
okay,
Or -1, sorry.
minus 1. Yeah. Awesome. So that's what our final function would look like for that guy. Good.
Can you explain how you
Okay, so this is kind of the explanation over to the right here. The a and c are always on the outside of the function, and the k and d need to go with x wherever x is. So x, because the parent function is 1 over x, the k and d will go in the denominator with that x. Okay, and then because the a and c are on the outside of that function, a ends up getting multiplied into the numerator. So whatever your a value is will end up here. Okay? Okay, so we're going to do these actual transformations on the next page, and then we'll already have the labels for our graphs there because we already did them. So let's do that. Karen, you okay there? Yeah. Look alive. Okay, so our earlier question tells us that our parent function is 1 over x. So we're going to call that f at x 1 over x. Our key points we wrote above. We're going to write them just so we can commit them to memory. Okay, it's also helpful if you write them in the proper order, or at least like the negatives together and the positives together, because those are each a chunk of the graph, right? They're each like part of the one curve. So at least have maybe your positives together and your negative x's together so that you don't get confused when you draw the points out. Okay, and then we have a horizontal asymptote. At y equals 0, which we know moves with the c value. And we have a vertical asymptote. Sorry for the messy writing on here. The board is just not keeping up with me. And we have our vertical asymptote at x equals 0, and we know that moves with our d value. Okay? I would consider these two things right here as part of the key points. They're a key piece of information that we need to transform. Okay, and then we're going to do some transformations. Just as a little review for you, this is how we set up our equations, right? The k and the d go with the x, the a and the c go with the y, and we want to make sure we do the reciprocal of k and switch the sign of d. Carla?
So when we have, or we're graphing, you're going to, sorry, two kind of questions. You're going to
Yep.
specify when it's 1 over x, right?
I will, yep.
Yeah.
Or you'll see kind of like an x in the denominator of the equation, which should tip you off that it's 1 over x.
Yes.
Yep.
Okay, and then you'll also know, because like before when we were graphing, you had like a preset of values that you use. So is this sort of the same when you're using -2, -1?
Yep.
It's always your default.
Yep.
Okay.
For this function,
Yeah.
yeah. Karen?
I'm confused where you got the blue stuff.
So these are kind of just like how we set up our equations based on what a, k, d, c we have. So a and c are changes to the y, and then the k and d are changes to the x. Okay?
But you didn't get that out of the equation. That's just something you do for everything.
Yes, this is what we do for everything when we do our calculations. Okay, so can someone help us set up our two equations on the tops here? Daniel.
Do I say that over here? Doesn't matter.
Well, here the k value is 1, so I don't think we need that part, right?
So x plus 1,
Good?
2y plus 1.
Awesome. Okay, so we switch the sign of the d value. Here our k value is just 1, so when I do the reciprocal of 1, I get 1. So there's no point in me writing that in front of x. But we switch the sign of this d value here, and then our a and our c value go with our y. Good? Okay, so let's add 1 to all of our x's here. That should be quick. Okay, and then our y's, we're going to multiply them by 2 and add 0.5.
Are you doing this in your head?
Yes. So you have to check and make sure that I'm right.
No, you do this in your head.
What does it even mean? Okay,
You have a hidden calculator, don't you?
I do. Just doing it. Okay,
Did you ever think you could memorize like numbers like this? Or like when you're a kid, you're like, oh, I have no idea how people do that.
Did you play with calculators as a kid?
no, I didn't. I was never good at stuff like this until I started teaching, and I had to do it kind of like on the fly.
Did they let
So.
you use calculators when you were doing like university exams or in high school?
Yeah. Yeah, we could use calculators, yeah.
No, it's all mental math.
Okay, where does my horizontal asymptote move based on these shifts?
-2.
So the horizontal asymptote will move with the c-value shift. So what's the c-value shift? 0.5. Okay, so my horizontal asymptote is going to move down to 0.5. Shifts up and down with the c-value shift. No, not a y-coordinate, right? So if you happen to have a point that goes on top of one of your asymptotes, that is a problem, for sure. We don't want that. Okay, and then where does my x move? So where would my vertical asymptote move as far as left and right? To 1, yeah, we have a d value, which is a shift right 1. So our vertical asymptote will also shift right 1. Okay, so basically, guys, we're just looking at these to determine our horizontal and vertical asymptotes. Pardon? Yes, if it was negative, we would write negative.
This sound like little children.
Okay, guys, so we're going to pencil in our asymptotes to start here.
Are we using the blue ones or you?
So actually, just a side note, we're actually not going to graph our parent function on here. I know I usually have you guys graph the parent function. Did you already do it, Olivia? She's ahead of me. So it's okay if you did. I might just suggest you grab out another color for your transform graph just so you don't get confused. When you guys do this on a test, I will have 2 separate graphs and you'll do the parent function on one and then you'll do the transformed on the other just because it gets confusing with all the asymptotes on one graph. Carla?
Sorry, for the blue one, can you just explain quickly again for when we're inputting into the equation at the top, or then
Yep.
getting those end results for...
Yep.
So we'd be like putting -2 into that and then getting like over x?
Yes, so I'm taking my x's and I'm adding 1 to all of them, and then I take my y's and I do this to all of them.
Just
2y plus
You don't
0.5.
actually represent 2y. It's...
So it's each of these individual y's that I'm subbing in.
No,
There.
it's just when you have 2y plus it, you're really just adding 0.5 to it. You're not actually putting y into the like final part of it.
No, because the y is always changing, right, based on what point I'm putting in there.
Okay. And then just, okay.
So the y just represents like all of these different y's that I'm subbing in
I
there.
understand.
Yeah.
It's just
So for the,
oh, because it's the same as x. Okay, I understand.
for the first one, you did 2 times -½ plus 0.5?
So I did this. Yeah.
Yeah.
Yeah, exactly. So I was putting it into the y and calculating. Okay, so the very first thing that we're going to do with this type of function is pencil our asymptotes in with dotted lines. And you're always going to make sure you label them with their equations. So dotted lines. Okay, if you already did the parent function, that's totally fine. Just maybe grab a different color. Okay, so this is important that we draw these. The reason being is that it helps me know whether my point calculations are correct. It also helps me draw the function because my graph has to curve around these areas. So I want to make sure I don't cross over them, and I also want to make sure that I kind of curve near them. So if I have written these in an okay order, the negatives and the positive, I've separated them out. This should be one of the curves, and this should be the other side of it. So we'll just graph them out. Okay, so that first set looks pretty good there. It's not crossing over any asymptotes. just as a side note, I have some people that decide that when they move their asymptotes, that's their new x and y axes. That's not the case. You're still plotting the points based on the original axes. The asymptote lines are just where we want to not cross over, okay? So don't make that your new x and y axis or anything like that. We're not moving the axes. Okay, so there's our first curve, and then the second 3 points should be our diagonal one over here. Warren.
Doesn't the original asymptote on the up on the top right corner, doesn't that cross over the line?
What do you mean by cross over the line?
Like you drew the dotted line at one, but the original asymptote crosses over that.
Which original asymptote are we talking about?
Blue and black. But the
Oh,
points
is
that
that
you wrote-
So that's a different function though, right? That's the parent function. So,
okay to cross them? Doesn't matter.
so the new function shouldn't cross over its own asymptotes, right? And then the old function, if the old function's like the parent function's asymptotes are at 0, y equals 0 and x equals 0, that function can't cross over the asymptote. Okay, so these are asymptotes for each individual function, right? So yeah, it's okay that this new graph crosses over right here, right? Because that's only an asymptote for the parent function. No problem. Okay, and then I just labeled my graph with our equation from the first page there. Final transformed
Original
equation.
lines for that are no longer valid. That's the graph. Like for when you're graphing.
The asymptotes?
Like the original ones.
Yeah, so these are only for this function right here. Yeah. Okay. Any other questions for this guy? Okay, let's try one more. And then you guys are going to do some practice. Okay, so same parent function. Do we need a break or do we want to finish here? It shouldn't take too long. What do you think? Okay, we'll finish it then. Okay, so we're all going to write the key points so that we can remember them, right? Because eventually we'll have to know these key points on our own. So I know it seems like we just wrote them above because we did. But we're going to write them again. Okay, so horizontal asymptote, y equals 0, and vertical asymptote, x equals 0. Sorry for my board here. Just a little side note here. Can somebody tell me why a horizontal asymptote that's on the x-axis is labeled y equals and not x equals? Why is a horizontal line y equals? Because aren't all the horizontal changes to the x's? So why is this called y equals 0? Elise? Think more about the coordinates on that line. So if this is the line, don't draw this. If this is the line y equals 0, what do all the coordinates on this line have in common? What's this coordinate right here? This is 1, 0. This is 2, 0, 3, 0. So why is this called y equals 0?
All the y's are 0.
Oh, okay, there we go. Perfect. Okay, so transformations. Does somebody bravely want to try the tops of the equations here? See if they can help us set it up. Ivana.
1/2 x minus 0.5.
There we go. Very nice.
Can I do the other one?
Do you want to explain to us, Ivana, how you got that?
Like in front of the x.
Shh, listen to Ivana.
We have the 1/2, well, 0.5.
So that's our D, right?
And then
And our K. So how did you get half there?
there's 1 in the front of not the 2, but in like A. What?
So A doesn't have to do with this though, right? Does it?
It's 1 over K.
So where does the 1 over 2 come from?
K. Reciprocal of 2.
Reciprocal of 2, okay. And then Ivana, can you tell me where the negative came from? Okay, yeah, so the D, we always have to switch the sign of that one, right?
Wait, I'm confused with the 1 over 2 thing.
Okay, so what's the denominator of a regular number? Always 1.
So you always flip K?
So we always use reciprocal of K.
What's the K in the other one?
The K, we didn't have a K in that one yet. Okay, you want to do the other one?
Yeah, I got this.
Okay.
You start with the A,
Yeah,
and the A is a negative.
yep,
And then you see the Y, which I don't know what that is. And then it's -1.
minus 1. Okay, good. Very nice. Okay, you guys are going to take a second here and calculate your points, okay? So calculate your points. That was very good. I'm going to... You do too. I love that uniform. So stylish. Okay, can somebody tell me what my new x coordinates are? Okay, shh.
-1.
-1.5, -1, yes. -0.75, yep. 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 Okay, good. And new y's, did anybody do the y's?
Yeah.
Alex.
First one is -0.5.
Okay,
Next optional one is 0.
okay,
Next one is 1, -3, -2, and -1.5.
okay. Agreed? Did we get the same thing here? Yes, yes, yes? Okay. Asymptotes.
Wait, I think I know how to do this. The horizontal one, can I say it?
Yep.
Is it -1? No, it's 1. I meant 1.
Is the shift up 1 or down 1?
Up 1. Down 1.
It's -1, right? Yeah. Okay, can somebody tell me where our vertical asymptote moves? Owen, Carlo, maybe one of you. Where does the vertical asymptote move? -0.5, yep.
How did we figure that out with the asymptote?
So this, basically, this one's going to be whatever your C value is, and this one will be your D value. No problem. The D value that you use here, or the flipped version of what's in the equation, whatever works for you to remember. Okay, so pencil in your asymptotes. We're almost done here. If you can hold on just a couple more minutes. Okay, and then we've got -0.5 labels on your equations here. Okay, just so you guys know, my expectation is that these are labeled x equals number, y equals number, whatever the number is, not just HA and VA, or HA equals number. I want the equations of the line. X equals for the vertical, y equals for the horizontal. What, Luca? Okay, and then we are going to pencil these in. Question? Okay, we're almost there, guys. Give me your attention for a few more minutes. Actually, more like seconds. Okay, so this one curves pretty close to the asymptote here, so just do your best. Try not to have your graph touching the asymptote. We want it just to kind of curve around. Goes pretty close, but it doesn't touch, which is good. If you happen to get something that causes your graph to cross over an asymptote, you have probably calculated something incorrectly, right? So that should raise alarm bells in your mind when you see something like that, where a point is on the opposite side of the asymptote and it's having you cross over and touch an asymptote. We don't want to have to do that, and you shouldn't have to. So just keep an eye out for stuff like that. And then we're just going to label it with our equation from page 1 there. Okay, this is just the equation that we came up with from the first page, Karen.
Yeah, I know.
Okay.
I just can't graph anything.
Okay, guys, so there are a couple things that I would be looking for you to do when you do any kind of graphing question. And I will probably tell you in the question, but I think some people still, I'm just going to close this video for now.